So the first thing I'm going to do is talk briefly about making a poster. I like to make posters in PowerPoint. If you go into PowerPoint, under the Design tab over to the side, there is a Slide Size tab, which allows you to select Standard, Widescreen, or Custom. When you select Custom, you can make the slide as wide or as tall as you like. Once you do that, you can add 3 text boxes into the slide. I like the one in the middle to be larger. That's where maps, tables, charts, graphs, that kind of stuff goes. The ones on the sides are where your text goes, like your various parts. In order to be able to figure out where to place these things, you need to turn on your guides and your rulers. So under the View tab, if you go down to the left there, about just left of center, you'll see that the ruler, next to it is a checkbox, and next to that is guides, and next in that box is a check as well. The guides are these sort of grayed checker lines that you see on the image. To move one, simply click on it, hold down your mouse button, and then hit the control key, and wherever you drag the mouse to and let go, you will drop that line or a copy of that line there. If you want to just move the line, don't hit the control key, just simply click on the line, hold it, and move it to wherever you need to go. And so once you've done that and you've added that next line in, as I have here, you can start positioning those lines to help you line things up. And again, I would put my intro, my question, and my data, and my methods on one side, my results, my conclusions, and my references on the other. Here I've added more guides, and once I added the guides, I could align my text boxes to fit, to hit, and to be centered on those lines. If you want to add in your maps and stuff, you want to save your maps as JPEGs and go up here to the Pictures tab and then add them in. Now today, what we're going to do in Saga, you're going to end up making a couple of things. You're going to take those things into ArcMap, and once you have them in ArcMap, you're going to export those maps as JPEGs, and then you'll take those JPEGs and import them as pictures into a PowerPoint slide, and you'll take that PowerPoint slide and save it as a PDF, and I'll talk more about that later. So to make them a good map, save it. You want to jack up the resolution. If you're going to make a big map, you won't have to do it for this exercise, but when you make your final project, you should. Excuse me. That middle section, it's not for just one single big map. It's for multiple things. It could be a giant map with other things around it. It could be a couple of maps, or it could be a moderate-sized map with tables and graphs, but it has to have at least one map. Anything that's in that section, you need to reference in the text sections along the sides. If it's in your poster, you have to discuss it in the text. It's easier if you don't write it in sentences, because then you don't have to worry about punctuation, and then you won't have any grammar mistakes. Write in phrases. So back to the layout, how things look. We can go to Picture and add it in. Now to tonight's lab. Here is where we're going to work in Saga, and I'm going to walk you through what I want you to do, and then I want you to do this and submit it. Step 1, download the data from class. If you're not on campus, it'll be a little trickier, because you're going to have to be very careful about where you save things, and make sure that you're not saving stuff on the C drive, on your whatever folder on Citrix. Because you'll need to have Saga, which is not on Citrix, and so you'll have to download that and install it on your computer. And then in order to work with that, you'll have to take the Citrix, do what you have to do there, and then save that data not on the server, but on your computer. And then you can do these things. So what you're going to do first is take the DEM that's in the data that I gave you for this lab. You're going to upload it into ArcMap, and you're going to use a conversion tool from Toolbox to convert the DEM into an ASCII file. Now, when you start looking for this thing, you'll see something, whatever you name it, and it'll end in .txt. That may or may not be the text file you're looking for, because the one that ends in .txt might be a projection file or another sort of file The way you can tell is if it has some sort of a logo in the middle of the picture of it, it's not. If you look at the details, in other words, if you go to the detail view in the folder where you have the data located, it will say TXT. I didn't think I was ever going to get that thing to run. Sorry about that. Okay, so here we are. We have loaded up the DEM. It could be any DEM. I just grabbed one here. This is the Harlan DEM. I don't know if that's the one that you have in your homework folder or not, but any one will do. Go to Arc Toolbox, go to Conversion Tools, go to From Raster to ASCII, and that's all you got to do for that. And you'll see that it shows up as this TXT file here in that middle column. When you look at that in a folder in Microsoft as opposed to in ArcGIS, there'll be multiple files there that have that same name, and some of them will end in .txt and some will not, and that doesn't matter. What you need to do is look at the details view, and then you can see which one it is. Basically, if it doesn't work, you added the wrong one, go back and add one of the others. There's only 3, so worst case scenario, you have to do it 3 times. In Saga, we're going to go to the Import Export Grids tool, and then we're going to go down and we're going to import an Esri Arc Info Grid. Now you're thinking, why do we make an ASCII file if we're going to import a grid? Because an Esri Arc Info Grid can read ASCII files. And so on the right side next to File, you see that I have identified the file that I needed. And below that there it says ASCII to Grid Options. And the various inputs are there. You can play around with those if you want. User defined no data values. There's -99999. You can take those out if you want. You can do any number of things. Once you load that DEM up in Saga, it'll look like this. Now, I want you to go back and do something that we did a couple weeks ago. I want you to create an aspect file from this. And so how would you do that? Well, there's all kinds of tools depending on the version of the Saga software you have. Under hydrology or something like that, there's a tool in there. You can go into file chain. There's one that calculates slope and aspect and some other things. But ultimately, the one you need is the aspect file for your final homework. But I'm going to show you what I want you to do with that aspect file, but I'm going to do it with this DEM here. And so underneath of the grid tools, there's one called calculus. And under the grid calculus, there's a fuzzify function. What this does is creates a fuzzy membership for the data set you're using. Okay, so what we're going to do here is you'll simply go over, put in your grid system and the grid that we're working off of, which will be your DEM or your in this case, well, for you guys, it won't be the DEM, it'll be the aspect file. You're going to create a fuzzified grid, and depending on the version of software, if you have the same version that I'm running on my laptop, it'll show you these control points A, B, C, and D. A is the point at which your value begins to transition from a 0 towards a 1. B is the point at which you consider that fuzzy function to be a 1 or a perfect score. C is the point at which that value ceases to be a 1 and begins to decline again. And D is the point where it goes back to 0. And so this is for an increasing and decreasing function. Now, other versions have a different format to where you can change, I can't remember exactly what it's called, but just like where this has membership functions and it says linear, there's another line there instead of these control points, and you can select either increasing, decreasing, or increasing and decreasing. And the one you'll select is increasing and decreasing. With increasing and decreasing, it'll give you 2 sets of boxes. Each box has 2 entries in it. The first one will be a to and a from. That is where your transition goes from 0, starting at the 2, all the way up to a 1 at the from the second box. The next one down is the same way, but it goes the other direction. That's where it goes from 1 back to 0. So those 4 boxes, starting at the top and working down, would translate roughly to the same thing as these A, B, C's, and D's. And here's an example where I have some range of data, and I pick the variables in and run it, and voila, I get this fuzzy DEM where new values that are in the range I want are 1s, so they're black. The ones that are in the maybe range are gray, and the ones that are in the no range is become white. And so you can see it still very much follows the pattern of the other one. Now with the aspect, when you calculate it, think of it as trying to identify a perfect location for a cabin using solar panels. And so you need a south-facing slope. South is 180 degrees. Doesn't have to be perfectly south, though. So what you would do is, thinking of your A box, you would start at something like 150 degrees. B would be 180, C would be 180, and D would be like 210. So it would go from 30 degrees before perfect to perfect, and then from perfect back to 30 degrees beyond perfect. And that would be what those values are. And what it would do is it would take everything between 150 and 210 and give it values, and everything else would become zeros. And perfect scores, in other words, due south 180 degrees, would be a value of 1. And so your aspect layer would look very different once you create a fuzzy version of it. And that's something that you could use for a lot of modeling purposes. Now, as far as the exact hows and whys to do it, if you think to the things we did the week before spring break, we went and ran a lot of different tools and hydrology tools and whatnot. You don't have to worry about filling this DEM. You can do a lot of this stuff if you would prefer in ArcGIS. You can take your DEM and create your aspect file, and then take the aspect file and convert it into an ASCII, and take that ASCII and load into this. That would be fine. Either way, it'll work. Ultimately, what I want is you to create a fuzzy-fied layer of the aspect file for your location. And then once you have that, you're going to export that back to ArcGIS, where you can make 2 maps, and then take those 2 maps and stick them in a PowerPoint slide that you save as a PDF that you then upload for your homework. Got it? Alright, well, if it didn't make sense or you want to hear it again, just rewind. So how do you export? In the same set of tools, the import-export grids, there's an export Esri ArcInfo grid, and all you'll do is identify the layer that you want. It will then create an ASCII file out of that. You can then take your ASCII file and upload it into ArcGIS. Now when you do that, it comes in as a text file. But in that wonderful toolbox in ArcGIS, there is a tool under the conversion tools under raster where you convert to raster. And if you expand it, there is a subtool that's called From ASCII to Raster. That one will work. Be cautious of the options, because one of them has to do with integers and floating points. And if you make it one way, you won't get the outcome you want, because it will make everything 1s and 0s and it won't work. So you'll want to set it to floating point. Alright, so that's the basics of it. If you get stuck, if you need help, if you're not sure how to do something, just shoot me an email. But before you do that, watch the video again and see if there's something there that'll help. Alright, good luck. Here's what the tool looks like.